Well, welcome to the first part of our lesson on right triangle trigonometry. In this lesson, we will be learning how to find the values of the 6 different trig functions, and these will be done just for the acute angles in right triangles. And then we will also learn how to solve some problems involving right triangles. So first of all, let's start off with talking about what is trigonometry. And basically, it's just the study of the relationships amongst the sides and the angles in right triangles. And the word comes from two Greek words, trigon, which means triangle, and metra, which means measurement. So we're talking about the measurements of triangles. There's 6 basic trig functions that we're going to be talking about. We will be focusing mostly on the first 3, sine, cosine, and tangent. And then the secant, cosecant, and cotangent are the reciprocal functions of the sine, cosine, and tangent functions. And basically, in any right triangle, we have 2 legs and a hypotenuse. And depending on where your reference is, what angle you're at, so if we're down here at angle theta, this is a Greek letter called theta, also called angle A down here. This leg would be the opposite leg. This leg is the adjacent leg, and then the hypotenuse is always the longest one, which is opposite the right angle. And we're going to define all 6 of these trig functions in terms of the ratio of the side lengths. So the sine of angle theta is always the opposite over adjacent. So it's opposite leg over adjacent leg. It's the ratio of those 2 sides. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. The cosecant then is just the sine flipped over. It's hypotenuse over opposite. The secant is the reciprocal of cosine, and that one is hypotenuse over adjacent, and then cotangent is adjacent over opposite. We have a mnemonic device that we use to help us remember what the ratios are for sine, cosine, and tangent, and you may have heard of this before. It's called SOHCAHTOA. And it just tells us the sine function is opposite over hypotenuse, cosine, the C is for cosine, adjacent over hypotenuse, and then tangent is opposite over adjacent. So the first letter is the trig function, and then the next 2 letters are the numerator and denominator of the ratios of the sides. So let's look at some examples. This one says find the 6 trig values for angle theta. So we have angle theta, which is up here at angle C. And in order to find the 6 trig values, we need to just fill in the ratios of the sides. Now, all of the sides are given to us. Sometimes we may have to solve for one of those sides, but in this example, we know all 3 sides. So if we're up here at angle C, 4 is opposite, 3 is adjacent. Remember, adjacent means next to, and then 5 is the hypotenuse. So the sine, if we're up here at angle C, is going to be opposite. Remember, it's SOHCAHTOA. Opposite over hypotenuse, so that should be 4 over 5. And then the cosecant is the reciprocal of that, which is 5 over 4. The cosine is adjacent, which is 3 over hypotenuse over 5. And the secant is that flipped over, 5 over 3. And then the tangent is opposite over adjacent. It doesn't use the hypotenuse, so that one's 4 over 3. And then the cotangent would be 3 over 4. So that's how you find the trig functions. Here is one for you to try. Find the 6 trig values for angle A using the same side ratios, but now you're going to switch from being up here at angle C to angle A. So the opposite is going to switch and the adjacent is going to switch. So go ahead and fill in all 6 of those trig function values. So we can also use the Pythagorean theorem if we know 2 sides of a triangle to find the 3rd side. Okay, and eventually, not in this video, but in the next video after this, we will be doing what's called solving the triangle. Solving the triangle is finding all 3 sides and all 3 angles. Right now, we're just going to focus on the side lengths in this video, and we'll work on finding the lengths or the measures of the angles in the next video. So here's an example. If the cosine of angle A is 2/5, we want to find the value of the tangent of A. So we're down here at A, this is our reference point. The first thing we want to do is to draw a triangle. You're not always going to be given a triangle, so I could just give you this in words and then you should draw yourself a triangle. And you will never be your reference angle will never be the right angle. It will always be one of the other two acute angles. So pick one to be angle A. And then we know that the cosine is 2/5. So fill in what you know. The cosine is adjacent over hypotenuse. So we know the hypotenuse is 5, and we know the adjacent leg is 2. In order to find the tangent of angle A, tangent is opposite over adjacent. So we need this opposite side here. Well, from the Pythagorean theorem, you remember that a squared plus b squared equals c squared, where c squared is the hypotenuse. So we can substitute in what we know. We know c and we know b, and we need to calculate a. So a squared plus 2 squared equals 5 squared. 2 squared is 4, 5 squared is 25. So we can substitute those in. And then subtract 4 from both sides. We get a squared is 21. And then taking the square root of each side, we get a is equal to the square root of 21. So to find the tangent of angle A, remember we said that's opposite over adjacent. So it's going to be the square root of 21 divided by 2, opposite over adjacent. And if we wanted to, and I don't think I have that to the nearest tenth. Sometimes they'll ask you to find that to the nearest tenth, in which case you would plug that into your calculator and then just round it to the nearest tenth. In this example, they just said find it. So square root 21 over 2 is the tangent of A. Now, in this slide, you should have been exposed in Algebra 1 or Geometry to special right triangles. Special right triangles are the 30, 60, 90 and the 45, 45, 90 triangle. Couple of things that I want you to be aware of. I will be giving you a quiz at some point asking you to fill in the side lengths. If I give you a 30, 60, 90, you need to know that the side opposite the 30 is the reference side, that's x. And then the hypotenuse is double that. And then the opposite leg or the adjacent leg to the 30 is x square roots of 3. So you will need to know each of those ratios for a 30, 60, 90. You will also need to know the relationship for a 45, 45, 90. Now remember, this one's called an isosceles triangle. So we call the legs x, and then the hypotenuse is just the square root of 2 times the leg. So it's x square roots of 2. You will need to memorize those side length ratios. The other thing I'm going to ask you to memorize is commonly used trig values. So for 30, 45, and 60, you will be using these quite a lot, and I want you to know the exact values. I will give you this table, and it'll be blank. I know it was blank in your notes, but I want you to fill in each of these values. Please fill them in carefully. And they come from these special right triangle ratios that we talked about right above. So for example, if I wanted to find the sine of 30 degrees, well, here's 30 degrees. Sine is opposite over hypotenuse. That would be x divided by 2x, and the x's would cancel, which just gives me 1/2, which is what I have right here. Okay, and then if I wanted to find the cosine of 30 degrees, well, I'm up here at 30 degrees. The cosine is adjacent over hypotenuse, so that's x square roots of 3 divided by 2x. And again, the x's will cancel, so I would be left with the square root of 3 over 2. And that's what you have in your table. So that's where these values come from. I'm not going to work through all of those, but you can just look at those and contemplate those a little bit to see if you understand where they come from. And one of the things I would like you to know or to recognize, if you just memorize the first row, so it's 1/2 square root 2 over 2 and square root 3 over 2. The first column, I guess, 30, 45, and 60. I usually write these going across the other way. 1/2 square root 2 over 2 and square root 3 over 2. Then this column just repeats. It goes backwards. Square root 3 over 2, square root 2 over 2 1/2. And then tangent is defined as sine over cosine. That's another interesting thing. So you can just take the sine divided by the cosine, and then simplifying the complex fraction will give you the tangent function. So anyway, I'll talk about that a little bit more in class, but that's something that's going to come up again, so you will be needing to memorize that. So in this example, we want to write an equation using one of the trig functions to find the value of x, and then we're going to solve the equation, and we want to round to the nearest tenth on this one. So we're given this picture, this triangle, and a 30-degree angle. We don't know the adjacent side, that's what we're looking for, but we do know the hypotenuse. So the first thing we want to do when we're looking at this is figure out what trig function would we use. And the trig function we're going to use uses the adjacent and the hypotenuse. So that's the first thing we need to figure out. The adjacent side is x, the hypotenuse is 8. What trig function uses adjacent and hypotenuse? And that would be the cosine function. So we know we're going to use the cosine function. The next thing we need to do is actually write an equation. So what we would say is the cosine of 30 degrees, is equal to the adjacent divided by the hypotenuse. So here is the equation right here. Cosine of 30 equals x divided by 8. Well, from your table that you will be memorizing, what is the cosine of 30 degrees? And the cosine of 30 degrees is the square root of 3 over 2. And then we have x over 8 on the right. And then to solve that, we need to get x by itself. So we're going to multiply both sides by 8. So I would just take in here and say times 8. And times 8 on the right-hand side as well. And these two cancel to leave us with an x all by itself. And then on the right-hand side, the 2 and the 8 cancel, and I'm left with 4 square roots of 3. Now this is the example where it says round to the nearest tenth. So we can plug this into our calculator. The square root of 3 is about 1.7, and 4 times the square root of 3 gives us 6.9 to the nearest tenth. So the value of, what did they ask us to find here? They asked us to find the length of this side. So the length of that side right there is approximately 6.9 units, whatever units we are dealing with. And that is it for this video. We'll see you next time.